Okay, first period, I went through some review, but I'm not going to go through quite that much because we started just a little bit later than I would have liked to. But the review talked about a central angle. Do you remember what was true about, the central angle and the arc that it cuts off? What was true about the central angle and the arc that it cuts off? They were the same. That's right. The angle was equal to the arc. Everybody understand that? You remember that, don't you? It's just a couple lessons ago. That the arc, the angle, the central angle was equal to the arc that it cut off. But I'm going to do another one. That was a central angle. Where was the vertex? That's a pretty easy question, actually, because it's a central angle. Where was the vertex of that angle? It was at the center of the circle, right? But this time we're going to do another angle that's not at the center of the circle. It's going to be actually right on the circle. Everybody see this? So right there. All right, so let's take a look at this angle right there. This is not a central angle. This angle right here does not equal this arc right here. Okay, this angle right here, wait for the announcement.
Excuse all middle school baseball players. Thank you.
Let's take a look. Let's label this thing. Let's call this A, call this B, and C. All right, so look at angle B. Everybody watching? Okay. Is everybody awake? Yeah. Come on. Let's snap out of it. Sit up straight, Chris. Sit up straight. Pay attention. Thank you. So watch. Angle B right here is not equal to arc AC. Arc AC is actually a lot bigger, a lot more degrees than what angle A is. In fact, it's twice as big as what this angle is. This angle, the vertex is not in the center of the circle. It's not on the. It's not inside the circle. It's not outside the circle. It's actually on the circle itself. We call this an inscribed angle. So we'll be referring to this a lot. So it's nice to know the name for it. It's an inscribed angle. An inscribed angle is when the vertex is on the circle itself. You might want to jot that down. I'm not going to, but you can. An inscribed angle is where the vertex of the angle is on the circle. Everybody got that? So the angle forms, right, if it keeps on going to here and to here, it forms this particular arc. Let's color that in just to make it stand out a little bit more. And I'll try to, oh, that's okay. I'll try to sketch my way around this arc. That's not too bad. Alright, so there we go. So this arc AC is twice as big as angle B. Now you can very easily see what they're going to do with this, don't you? They'll give you angle B. Angle B is, I don't know, 30 degrees. So if angle B was 30 degrees, tell me what arc AC is equal to. 60. What if arc AC was 80 degrees? What would angle B be equal to? Be 40. Simple, isn't it? You with me? They could even give it to you in terms of x, couldn't they? They could say this is, I don't know, 3x plus 1, and this is, 2x minus 4, something like that. So what do? Right, double this one, and you double this one right here, the angle, and it equals the arc. Right? We've been doing that all year, haven't we? Stuff like that. All right, it's just different pictures, different figures, and stuff like that. All right, we good with that? That's not too bad. Let's do this. Let's go blue this time. Watch this. What if I did another inscribed angle? So that's one theorem, okay? That the the inscribed angle is half of the arc that it cuts off. What if I did this though? What if I draw another inscribed angle? Oops. Let's take that down a notch right there. Let's go to this. Now look, examine this for half a second. Take a look at this angle. We'll call this angle, what are we on now, D? Alright, we'll call it angle D. Tell me something about this angle compared to, I don't know, anything in here.
Angle D would be the same as angle A.
Is angle A? This one up here?
No, it's angle B.
It's angle B. Why is it the same as angle B? Because it's also half of AC. That's right. Because this angle right here, look where it hits. It hits right here at A. There was no coincidence. I did it on purpose, okay? It hit at A, and this other part of the angle hit at C. So what did it cut off? It cut off arc AC, didn't it? So this must be half of AC. Angle B must be what? Chris, I don't need that, please. So angle B is also what? Half of AC. Well, AC is not changing, is it? AC is the same arc. So let's just pretend like AC was 80 degrees. Is that all right? So let's say AC was 80 degrees. Then what would arc, or I keep saying arc, what would angle B be equal to? It'd be 40, wouldn't it? All right. What would angle D be equal to? 40, because it cuts off the same exact arc, doesn't it? That's easy, isn't it?
And then
Let's do one more. I could keep going, couldn't I, if I wanted to?
would angle, the two vertical angles
These
would be
two?
the same, and then angle A and angle C would be the same. Because aren't they similar terms? Because the vertical angles theorem and that they both have.
Yes, absolutely right. It's a good call. I didn't even think about that. Watch. These are equal to each other because they're vertical, right? So I got two angles equal to two angles, right? So that must mean what? The triangles are, they're similar to each other, right? So what must be true about this third angle? The third angle must be equal as well. All right? Okay? I don't think you can say that they're congruent. Nah, you can't say they're congruent, but you can say that they are similar to each other. Good call on that one. Let's do another one just for fun. Watch. If I went way up here, just showing you, I'm not really trying to hit any kind of magical place or anything. Alright. So what would this yellow angle right here be equal to? Cuts off that same exact arc, right? So it's half of 80. They're all half of 80. So we actually have a theorem that says this, that an inscribed angle that cuts off the same arc are equal to each other, okay? Or any, I forget exactly how they say it. It's in there somewhere. It says if two inscribed angles of a circle intercept the same arc, all right, and that's what they're doing, right? You could even say two or more, couldn't you? If two or more inscribed angles intercept or cut off the same arc, those inscribed angles must be equal to each other, all right? That's basically what it's saying. We good with that? It's pretty easy to see, isn't it? All right. I kind of like this next one. This is, to me, when I first saw this, I don't know if I would say I was blown away by it, but I was mildly interested. How's that? It's a little different than saying I was blown away by it, but you get the idea. Let's draw a diameter right there. Okay, and what I'm going to do, let's use a different color. Watch this. What I'm going to do is I'm going to draw an inscribed angle, but it's going to cut off right here and right there at the ends of that diameter. I didn't put any numbers in here at all, did I? So what do you think this angle is right up top here? It's a right angle. Why? Matt? Just because it looks like a right angle? Is that what you're going by?
Yeah.
Because the book says.
Because the book says so. Come on, what kind of answer is that? Joanna, tell me. Did you look at it just because it's a right angle? Because it looks like a right angle? Tell me why, though. Give me a good reason. Because it's the what about the diameter?
Oh, it's opposite hypotenuse.
Well, but you don't know it's a hypotenuse unless you know that's a right angle. All right, Rachel, go ahead.
Because the other half of the circle is 180 degrees.
Okay. Yeah, it's a diameter. So what is this arc right here? Whoops, didn't mean to write that. What is this arc right here? It's 180 degrees, isn't it? Okay, so look what it did. You had an angle that cut off right here and right here. Actually, I should do this one down here, right? It should be this arc. This arc down here, it's actually a semicircle. How many degrees is a semicircle? 180 degrees. So what is the inscribed angle? The inscribed angle is what? Half of the arc that it cuts off. You see that? So it cuts off a 180 degree arc, which means it's got to be half 180, which is what? 90. All right, so that has to be 90 degrees. Didn't just happen to look like it. I didn't just draw it at that magical spot right there to make it 90 degrees. I could have put that anywhere, right? I could have put, I don't know, let's say right here. I could have done here and done what? Cut off a 180 degree arc from there to there. You see that? And what kind of angle do we have here? It's a 90 degree angle. It's a right angle. I could keep doing that all day long, couldn't I?
Yes.
If I wanted to. Let's do it one more. Let's go like real crazy, like way down here. So that would be about right there. And that would go way down here like this. What kind of angle do we have though? That's still a 90 degree angle. You get it? I could go anywhere along the circle and that's always going to be a 90 degree angle. I don't know. I think that's kind of cool. Don't you? Alright, so I can, all I had to do was draw a circle, draw a diameter, know how to draw straight lines, and I could make it a perfect 90 degree angle. You alright with that? Okay. Let's move on. We're cruising. Oh, we only got one more to do. You kidding me? And bell's gonna ring any minute. So let me just do this real quick for you. Watch. Let's do a different color. Watch. If I was gonna, oops. Actually, sorry. We'll keep that white, and then this next one is gonna be yellow. All right. Here we go. Watch. I'm gonna draw 4 sides, but notice what's true about all the vertices to these sides. They're all on the triangle, aren't they? So look, I've got a whole bunch of what kind of angles? What kind of an angle would that be considered? The vertex is on the circle. It's the first word we talked about today. What is it?
Inscribed.
Inscribed angle. That's right. This is an inscribed angle. So is this. So is this. So is this. Why are they inscribed angles? Because they're on, right, the vertex is on the circle itself. Okay? So they're not just a whole bunch of lines. What did I form? I formed how many sides? Huh? 4. 4 sides. So what do I call this? It's a quadrilateral. All 4 vertices are actually on the circle, so what do you think I'm going to call it? An inscribed what? Quadrilateral. That's right. Alright? So that's an inscribed quadrilateral. Now, what's kind of interesting is this. We kind of learned something like this back when we did the parallelograms and all that. But this is not a parallelogram. Okay, I don't know it's a parallelogram, but it is what? An inscribed quadrilateral. But at least one of the things are true about this, just like it was a parallelogram, that the opposite angles are not equal to each other. Now look, they're obviously not equal, are they? That's an acute angle. What's that? It's obtuse, isn't it? There's no way they're going to be equal to each other. But what else do you think they are? What's another thing that we used a lot of? Supplementary, exactly right. So angle A plus angle C, they're supplementary, so what do they equal? 180 degrees. What else do you think might be supplementary?
D and B.
Yeah, D and B are supplementary as well. I'll just write that down. So angle D plus angle B is also equal to 180 degrees. So the opposite angles of an inscribed quadrilateral are supplementary. Alright? We got that? So they are supplementary to each other. Alright? So they add up to 180. Yes. Alright, so that basically covers everything that that I need to cover. Let me, where's my book? What's the second circle called?
I mean, the second example you did, no, they all had.
Well, it just says that the one with the 90 in it. Yeah, it was just an inscribed angle that cuts off a semicircle. That angle would be a right angle. Okay, so here's the problems you got to do. So write these down.
Students need to report to the office. Elena Creek, Matthew Southers, Elizabeth Creek, Kyle Berry, Kate Kazalka,
Matt, you getting all
and
these?
John McMasters. Please report to the office.
Matthew,
Thank you.
why aren't you writing this down?
About
Well, you're packing up and walking out.
Is that it?
I didn't say class was over yet.
Is that it?
That's it right there. Okay, 11 to 20, 23 to 30.
Great, I get to do this speech in poetry.